think back to yesterday's lesson. We thought again about a factor that we've got to consider when we recommend a site for the TarPul. And that big factor is erosion. Who can quickly tell me the meaning of erosion? Trent.
Once something is weared away by wind, water, or ice.
Excellent. Okay. And so you all did a prediction on what part of rivers will wash away or erode the most and which one will erode the least. And you got some background knowledge by looking at an aerial view of a river from what year? 1920. And then we fast forwarded how many years? 54. And we got to see the difference. So it took 54 years for those changes. They may not be major, but look, there's a part that eroded, got more that curve got more pronounced. So we kind of learned that it doesn't happen overnight, right? It could take 50 years, 100 years for you really to notice a difference. The importance of compaction. Give me a synonym for compaction, Lucas.
It's whenever you press something down to make it like more stiff or something.
All right. And so what we did yesterday was we did an experiment and we tested what it would be like to compact rocky soil or organic soil. And what did we find out about compaction? Alyssa, does it make a difference at all?
Yes.
Okay, can you explain that to everybody?
Like if you when we compacted ours a half of an inch, we have 43 weights.
Okay.
And when we compacted it a fourth of an inch, we had 32.
Okay. So does everybody agree compaction makes the TarPul stronger? Okay. So we know there's lots of factors to think about when we're going to predict today a recommendation for the TarPul site. We've got to think about erosion, we've got to think about compaction, and most importantly, we've got to think about the location, and especially where the village elders already want the TarPul to be built, which is at what site? D. Site D, okay? So today we're moving along here in the engineering design process. We have asked all kinds of questions about geotechnical engineers. We've asked questions about erosion and compaction, and we are now ready to imagine an idea, which is choosing a site that we want to recommend to the villagers. But keep in mind, you've got to think about how many sites away your choice is from D. All right, because D is where the elders, the villagers, want the site. So let's just say it's A, okay? How many sites away is A from D? 3. How many sites away is E from D? 1. Just 1. So that's how you're going to fill in that little part there. Think about, is that site that you're recommending, is the river very curved, just slightly, or straight? So we need to have a quick discussion about that. If you're looking at your site map, we've got to make sure that we all agree what is slightly curved and very curved. All right, let's think. A, what would you call it? Straight? Okay. B, very curved. C, ooh, I'm hearing some. Let's see your votes. Slightly. Very. I agree. Very curved right there. How about E? Straight. Straight. Now here, look at slightly. Slightly. Okay, so we all agree. Okay? Now, back to your imagine. When you get down to here, you're thinking about, let's just pretend again you picked A. Look at side 1. What type of soil is at A? Rocky. And what's at side 2? Organic. So you can see side 1, you've got to circle what's on that side of the riverbank. Side 2 of the river, what type of soil. And now, here's the part you've got to have a lot of discussion about. Are you going to compact, if it's rocky soil on side 1, are you going to compact it at all? Are you going to compact it down to that second line, 1/4 of an inch? Or are you going to go for the full Mac Daddy of compaction, 1/2 of an inch? All right? Now you can make a different decision over here. Over here, side 2 is organic. Okay? Doesn't have to match this side. You might make a completely different decision. And then finally down here, what are some advantages? Give me a synonym for advantages. When I say what's the advantage, what does your brain think?
I think that it would be like something good about it.
What are the good things about the site that you chose? Let's just think about D. That's where the villagers want it. What's an advantage to pick in D? Ethan?
That the villagers want it right there.
That's where they want it. That's what the tradition has been for years and years, all the way back to their ancestors. They've always had a bridge in that spot. What's another advantage? Alice?
It's like really close to the village and the clinic.
Close to their home and close to their clinic. Because you know there's other Aussies out there. Not just one Aussie that's sick. There could be other grandmothers in the village. And when you think of disadvantage, Trent, what does your brain think of? Disadvantage.
The bad thing.
What are the bad things about D? Abby?
It's curvy.
It's curvy. What's the big deal about a curve in a river? Erosion happens. Do we want the poles to fall into the river and wash away? Absolutely not. So you and your team are going to spend a few minutes listing advantages and disadvantages. Any questions about how we're going to imagine this morning? All right.
I picked E. Yeah, me too. I picked E. I like E. It's close to D and it's straight. But it's all organic, so it's weak. H is slightly curvy. I think A is close to. It's just H is straight. But H is way far away. Sorry. Yeah. It's X. I think we should do E because E is close, and if we had it's organic soil. I think it should be A. TarPul. Yeah, now that you say it. It's organic soil. You know why H? It's organic soil now. What? E is organic soil. Yeah, but it's weaker. Exactly. So it's mixed. I say A. Do you agree, Natalie? I don't really say that. Yeah, you just walk to the school. It's F or E. You drop Suman off, and then
Are you all still discussing what site?
We're stuck on F and E.
You're stuck between F and E. Okay.
And they think
so how many of you want E?
me.
You want E, and how many want F? All right, let's hear your arguments for E as opposed to F.
Well, E is closer to the clinic
E's
and the school.
Closer to the clinic and school.
And it's close to the village. So yeah, it's close to the
What do you notice about the soil types for E and F?
They're both organic.
Okay.
But rocky soil would erode first.
Rocky soil is going to...
Well, it depends on how big the rocks are. If they're giant rocks, it would take a long time for it to go away.
What if it's sand?
Sand would go away
It doesn't say
faster.
what type of rocks it is.
Right, but in our models, they're little pebbles. But it sounds like you've narrowed it down to E and F. True? Okay, I'm going to come back and check on you. You've got to narrow it down because a lot of people are already down here talking about the advantages and disadvantages, which you've already talked about. But we got to get it down on paper like an engineer would.
Alright, I think we should do F.
3
on 1. Let's
3
do
on
E.
1.
Why? Because it's closer to the clinic. But it's closer to a curve. F you have to walk to.
It's closer to a curve.
So?
Yeah.
That's what are legs for?
Yeah.
No! The Audrey cannot walk because she's sick.
Yeah, so somebody will carry her.
But
Or
she's
help her.
well after all.
She's well now.
She's well. Come on, he's closer and straight.
Oh
and
my
then
God.
to the village. 3
on 1. 3 on 1.
That's it. We're doing rock, paper, scissors.
Alright, fine.
It looks like you've wrapped up your next step of the engineering design process. You imagined a location that you think you want to recommend to the village elders. I'd love to hear what you've imagined. Let me hear from somebody that picked site H. Huh? Why do you suppose nobody is going to recommend H, Kanye?
Because it's far away from the clinic and school.
Ah, any other reasons?
And it's slightly curved.
Big deal about that is that big E word, erosion. I'd love to see who's picking site G. Huh, F. Team 6 is picking F. Lucas, tell us why.
Because it's, well, it's low eroding, it's straight, and it's close to village and close to site D.
Who selected E? Ah, 2 teams have chosen site E.
It's straight and there's not much erosion. Site E is close to the school and the clinic, but the bad reason is the soil's organic and it's not as strong as rocky soil.
Oh, boy, you've convinced me for sure. All right, site D. Oh no, that's exactly where the village elders want it. Nobody's going to give the village elders what they want. Why not, Aubriana?
Because it's curved.
Would you say slightly or very?
Very curved.
Okay. Site C. Site B. Site A. Whoa, team 3, 4, and 5. Give me a good reason why, Lexi. Why
It's
site A?
close to the school and it's straight.
Straight part of the river. You all are really thinking about erosion and the impact that it could have. All right, now I want to hear from you about what your team is thinking about compaction, because we know in the real world it's not as easy as what we've modeled. You've got to bring in big equipment to pack down that earth, and that costs a lot of money and it takes a lot of time. So I want to hear what you've decided to do about that. Everybody think about side 1 of your chosen site. Give me a 0 if you're compacting at 0. Oh, nobody. So that shows compaction is extremely important in the strength of your TarPul. Give me a 1/4. Okay. 3 different teams. Give me a 1/2. 3 different teams are going to compact that far. All right. So now you have done 2 steps of the engineering design process. And we have to be formal about this. Engineers have to write it down. Sometimes they sketch it. We're going to give the plan to the village elders in Nepal. Okay? So if you flip to your next page, there's your plan.
So we recommended compacting the soil around the TarPul.
It's both 1/2.
Yeah, so they're both 1/2.
Instead of sharing our plan, we're going to do a table tour to check out everybody's plan so that you'll know what everybody's up to, what everybody's going to recommend to the village elders, okay?
They're doing straight.
We're doing the same thing that
Straight, and then 3, and then B, both, and then 0 compaction and 1/4 of compaction. Let's see here. F. Fascinating. 1/2. It's going to be straight, organic soil. Cool.
I love how lesson 4 makes them really pull together nicely everything that they've learned up to this point. And they make some solid recommendations and the energy that happens at each table, and they're respectfully listen to each other. I had a situation today during lesson 4 where 3 kids were like, we've got to stick with A. And another kid was adamant it needs to be E. And I said, keep talking. What are the advantages of site A? What are the advantages of site E? So I love lesson 4 because it gives them that opportunity to really have some rich dialogue and really get into that good solid debate about different factors. Tips for teachers new to this and especially to lesson 4. One thing that I've noticed when preparing the plastic containers that have the organic soil and the rocky soil, you need to have plenty of them, because I was preparing them and I'm thinking, oh, 8 rocky, 8 organic. Well, lo and behold, when they did their first design challenge, a lot of kids were picking organic on both sides. So I had to do a little scrambling. I don't think any of the kids noticed, but make sure you have plenty of each container. Another tip is it will settle overnight because you're marking on the containers the soil surface line. Under that, you're marking 1/4 of an inch. Under that, you're marking 1/2 an inch for their compaction. And sure enough, I'll pack all the containers, and overnight they settle. And sometimes you're scrambling around in the morning, you know how it is, and sure enough, they've settled, and you hand those out to the kids, and they're like, well, it's already compacted. So I think a good tip is have a huge container of soil just available and maybe a big container of rocky soil.